Second big one in HANA is the row and column stores. The column stores are basically like that. So columns, they are not all uniform, and I'll get into the reason for why that is. But basically, you take a relation which sort of looks like a table or an Excel spreadsheet and store everything about it in columns. And so this is column store, and you have the row store, which is more traditional, except our row store is in memory, and it has some pretty amazing inventions like optimistic latch-free index traversal, which is when you have to store a transaction in memory. You have to be able to do that without locking up the whole thing, and so we do latch-free index traversal. So this was a new data structure that Sang and his team had designed, and so on and so forth. So we have both of these, and the benefits, of course, of the row store are that you can do transactions quite quickly. The benefits of the column store, like I already talked about, is that you can do analytics, reads dramatically faster. How much faster? Well, I mentioned already the number. I hope you guys remember this: 3.5 billion scans per second per core. And when you think about enterprise data structures, one of our sales order, for example, or the manufacturing order, or the account segments, the BSEG, which is the core, one of the two core tables. BKPF is the other one. In our financial application, this is the headers, and this is the line items, the accounting line items. And the BSEG table has something like 320 fields in it. The document name, number, type, is it credit, is it debit, it's the address, is it overdue or not, and 320 pieces of information about that. And so it is a very, what we would call, wide data structure. And when you have such wide data structures, and whenever somebody, a normal human being, wants to know something about, let's say, accounting line items, our brains have the ability to handle maybe 10, 20 out of these 320 fields. So in a columnar data structure, that means that you just pick out the ones that you need, that you're interested in getting information on, quickly assemble them into the result and demonstrate that. In a row store, in a traditional disk-based row store, you are going to the disk, you are grabbing things row by row, and then after you have retrieved all the rows, then you are identifying the columns out of the rows that you're looking for, and then pulling this information up. So it's dramatically slower. Here, not only do you get just the columns that you're interested in, but in fact, do that massively parallel, because you can assign different cores to grab the different columns. In fact, you can take more than one core for one particular column, and this is the fancy cocktail thing that I told you about, the intra-operator parallelism. So that's basically the idea. Now, traditionally, one of the myths about column stores was that they were slow when it came to transactions, and our teams worked super hard over the years to make sure that this is not the case. And the way we do that is actually a bunch of quite clever, amazing techniques. So you have the basic column store here. In addition, we have a less optimized column store that we call the delta store. So this is the main column store, and this is the delta column store. And what happens is that transactions come into the delta very quickly, and every once in a while they get merged through a process called the delta merge into the main store. And then whenever there is a question, by the way, it's not slow. So whenever there is a question, if there is information that is partly in the delta and partly and mostly in the main, then you can do a join between the delta and the main. And if everything that you're looking for is in the main, then of course it is really, really fast. And one of the things that we have added recently into this design of the delta and the main is we have added a concept of what we call an L1 delta, which is a variation on this row store, which sits as a buffer in front of the delta, and this can absorb transactions really, really fast. Like, let's say if you are capturing events coming out of every airplane of your airline company that is flying in the sky, and all the engines of every airplane in the sky are sending out events at the same time to the ground. You want to absorb like 1,000,000 events per second, or you want to capture every trade that is going on in Wall Street, or you want to capture, every piece of instrumentation that is coming from all the tractors of John Deere that are on the field, or MRI machines of Philips or Siemens or General Electric, or any of these kinds of things which are sending out super fast transactions. Those can come into the L1 delta, and as the transaction gets closed down, or when the system gets a breathing room, you dump them into the delta or into the main as things would happen. And then in the meantime, if there are questions that come in, you do joins across these three things. So this is an extremely novel and super high performance architecture which enables us to run very, very fast queries and columnar operations, while at the same time preserving the benefits of the row store, and absorb the transactions at a very high speed into the row store. And when you think about it, the world sort of works like that. If you ever go to China and you have a translator who is sitting there and translating things for you, and you're speaking English super fast, and then there is this guy who's continuously translating the thing in Chinese to the other people who are sitting in the room, and every once in a while you get so fast that he has to take out a little pen and start to write down his thoughts in English. That is sort of like the L1 delta buffer here. So this is the main design of the central structures of HANA. It's the column store. That's our main invention. And in addition, the parallel row store that enables us to be able to achieve a dramatic performance on for not only for analytics but also for transactions. And keep in mind, one of the things that people get confused about in HANA is that people think that the row store is for transactions and the column store is for analytics. This is not the case. You can do row and analytics and transactions in the row store. You can do analytics and transactions in the column store. And we have some attributes of the row store inside the column store as a way to buffer up the transactions in the row. So it is a completely without compromise design, and we were able to do that because we started from scratch, and the other people have decades of legacy that they have to protect, and it is much more difficult for them to do so than for us.